Greetings to all learners doing technical mathematics at grade 12 level. However, grade 10 and grade 11 learners can also watch or listen, as well as mathematics learners grade 10, 11, and 12 can also listen. But this topic is meant for technical mathematics learners doing grade 12, since it is going to be linking to their topic or the level at which they do trigonometry at in grade 12 level. So as you can see, as I have mentioned, today's lesson is on trigonometry, and this is going to be lesson 1 of the 5 lessons that we are going to do. We are going to do it step by step because I want us to start from basics so that we can link it well with grade 12 trigonometry in technical mathematics, which by the way is also done in mathematics. So we are starting from the introduction of a solution of triangles, which is done in grade 10, starting by a right-angled triangle, and then in grade 11 we introduce a non-right-angled triangle. But as I mentioned, today's lesson is on trigonometry and our target is grade 12, but grade 10 and 11 learners can also watch, as well as mathematics learners grade 10, 11, as well as grade 12. By the way, the presenter is Mr. M Njomeni, who is coordinating the subjects at provincial level. Now, I want us to just look at triangles. Basically, there are different types of triangles, and they are named according to sides and angles, right? But we're not going to be focusing on that because that is more on Euclidean geometry. But in trigonometry, we are able to find the unknown sides of those triangles as well as unknown angles when given the magnitude or magnitudes of the minimum required number of angles as well as side or sides, right? Now, in trigonometry, we are going to look at the two main types of triangles. We're just going to categorize them into two. We know there are many ways of categorizing them. Of categorizing the types of triangles, but we are only going to focus on the main two ones, which is the right-angled triangles as well as the non-right-angled triangles. Now, in our lesson, we're going to look basically at the two types of triangles. Now, with the right-angled triangles, we are going to see that there will be an angle 90 degrees somewhere. So a right-angled triangle is a triangle with at least one of the sides being 90 degrees. And by the way, the side that is opposite will be called the hypotenuse. The side which is opposite, which means this side, will be called the hypotenuse. So there again, there is 90 degrees there, and the side that is opposite will be called the hypotenuse, which means this side will be called the hypotenuse of that. And then we also have the non-right-angled triangle. The non-right-angled triangle, which means there is no angle which is 90 degrees. All these angles are either less than 90 degrees or one is greater than 90 degrees, like it is the case there. There is greater than 90 degrees, that one. This one we call acute angled triangle, this one obtuse angled triangle. But I don't want to go there, just want you to understand that this is non-right angled triangle. In other words, there is no angle which is 90 degrees. Right angled triangle, one of the angles is 90 degrees. Non-right angled triangle, no angle is 90 degrees, or none of the angles is 90 degrees, right? Right. Now, I want us now to look at the right-angled triangles first. When we look at the right-angled triangles, we will realize that there are two main things that will be useful there. It will be Pythagoras theorem as well as the definitions of trigonometric ratios. Pythagoras theorem as well as definitions of trigonometric ratios. Now, always remember that whenever you're talking about triangles, you can't run away from Euclidean geometry, especially when it comes to angles. For instance, if you know two angles in any triangle, then you know the third one, because when you add all the three angles, you must always get 180 degrees. So learners, you must keep in mind that at the end of the day, this issue of triangles is also part of Euclidean geometry. So keep in mind your Euclidean geometry, especially when it comes to sum of angles of a triangle. Please use that to your advantage whenever necessary. Right. So I want us to look at the use of Pythagoras theorem now. What is Pythagoras theorem, or where is it used? Right. I will start from the bottom and say, in words, we say the theorem of Pythagoras states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. The square on the hypotenuse side is equal to the sum of the squares on the other two sides, which means Pythagoras theorem states that in this triangle, for instance, if there is small letter a there is small letter b there, and then there is small letter c there, it means that now c squared will be equal to a squared plus b squared. C squared will be equal to a squared plus b squared. So c squared will be equal to a squared plus b squared there. C squared will be equal to a squared plus b squared, as you can see there. So let me go up there and say the Pythagoras theorem links the length of the sides of a right angled triangle, as I've explained, that c squared is equal to a squared plus b squared. That's how Pythagoras theorem is. Now we are going to use it to calculate sides of a triangle, right? Especially if two sides are given and you are short of one, then you can simply use your Pythagoras theorem, right? Now, let's look at the definitions of trigonometric ratios, which is where we are. The definitions of trigonometric ratios, please note the following. We're still talking about right-angled triangles. Please note the following. If we talk of the hypotenuse, we are talking of the hypotenuse as the side opposite to the right angle, as I indicated before. It is always the longest side of a right-angled triangle. So please note that it is always the longest side of a right-angled triangle. And then if we talk of an opposite side, we must pick an angle and say we are talking about this angle. And then we look at the side opposite to that angle. Adjacent angle, or rather adjacent side, is the side which is next to the angle. And it is one of the arms of that particular angle we are talking about, right? Now, perhaps let's explain further so that we can see. If, for instance, we're talking about angle theta in this triangle, if we're talking about, angle alpha in this triangle, this is angle alpha, not angle theta. If we're talking about angle alpha here, then which side is adjacent? The side which is adjacent is the one which is next to. So it is this adjacent side. And the side which is opposite is the one that is far away from that one. So which means it is that side which is opposite to angle theta. And the hypotenuse, as indicated, it is always the longest side, and it is always opposite to 90 degrees, opposite to 90 degrees. If now there is beta somewhere there on top, because we must not be stereotypes and think that the alpha or the angle in question will always be this one. It can be anywhere. We must just look for the side opposite to this angle beta, which is that side, right? And the side adjacent, which means next to, it is this side. And of course, the hypotenuse is the longest side and is always the side opposite to 90 degrees. So we can symbolize the opposite side by op or by O, adjacent side by arch or by A, hypotenuse as by hype or by h, right? Now, in right angle triangles, again, we're still continuing, learners. Definition of trigonometric ratios, that's the subtopic of that. We use what is called SOHCAHTOA. What is SOHCAHTOA, or what does it mean, SOHCAHTOA? It's just a way of having a common understanding of how the definitions in trigonometry work. And then it means SOH simply means sine is equal to opposite over hypotenuse. That's where this SOH comes from. Sine is equal to opposite over hypotenuse. That is SOHCAHTOA. Sine is equal to opposite over hypotenuse. And then cos is equal to adjacent over hypotenuse. So cos is equal to adjacent over hypotenuse. and then tan is equal to opposite over adjacent. So tan will be equal to opposite over adjacent. That's how it is. This SOHCAHTOA, that's what it means. Now, there are many ways of understanding these definitions. Some people, for instance, come up with different ways. For instance, I've just put another one there, which means for SOH, which means sine is equal to opposite over hypotenuse. For cos is always adjacent over hypotenuse, and for tan is opposite over adjacent. Some learners may understand it as studying our homework can always help to obtain achievement. So it's just any way that learners can use to understand it, you can use it. But remember, this is not something which you have to write when you are answering your examinations. It's just a way of you understanding it. For instance, in this case, if you are to focus at angle C, there is angle C. If you are to focus at angle C is this angle. If you are to focus there, you will notice that sine of angle C will be opposite. Opposite to C is that angle, that side, which means it's AB over hypotenuse. Hypotenuse is AC, right? So sine C is opposite, which is AB over AC, while cos, remember cos is adjacent over hypotenuse, so cos will be adjacent, which is BC over hypotenuse, which is AC, and tan will be equal to opposite over adjacent. Tan will be opposite over adjacent. Opposite over adjacent, which means it will be AB over BC. That's basically a way of understanding that. Right. Now, if we continue there, we need to do now what you call examples of this. But before we do examples, I would like us to briefly talk about the non-right-angled triangles, which we are not going to get into details in this lesson. We are going to talk about them in our next lessons now. In a non-right-angled triangle, we are going to use the sine rule, the cosine rule, as well as the area rule. But for this lesson, for this lesson, we are going to talk about right-angled triangles. So we shall talk about these, that is the sine rule, cosine rule, as well as area rule, more in the following lesson. But for now, we are going to talk about right-angled triangles. So I want us now to look at few examples on how to solve the right-angled triangles. Now, we are going to use SOHCAHTOA, we are going to use Pythagoras theorem when necessary, right? So I want you to look at this example and keep that example, because that is the example that we are going to do. I want you to look at that example. If you are to consider the diagram below and you are asked to determine the following: 1.1, the magnitude of angle Q and angle R. So angle Q is that one, as well as angle R is that one. So we are looking for this angle as well as that angle, right? And then calculate or determine the length of PQ. So we need to also calculate that length, the length of PQ. So we need to calculate these two angles in this triangle. Remember, we already know that that angle is 90 degrees. That's what makes this triangle a right-angled triangle. Now we have to find these two other angles in that right-angled triangle, right? So I want you to take this one down in your books. You can just draw quickly the diagram, the right-angled triangle, and put 24 and 25. Remember, the hypotenuse is 25 and PR is 24, and then you are going to solve that one, right? I will prefer that we do those ones practically. In other words, I would like to write as I explained to you, so which is going to happen later. So obviously, you are going to calculate 1.1 and then 1.2. Then I want you to take again example number 2, which is what we are going to be talking about, example number 2, right? And as an example, second example, which I want us to take in order for us to understand this thing better, how to solve right-angled triangles. Remember, I said you can't run away from Euclidean geometry. So I want you to be taking down this triangle especially. I want you to take down this diagram especially, because when we ask questions or when we are solving these, we're going to be solving them using this diagram. So please take down this diagram. I said you are going to use Pythagoras theorem, you are going to use SOHCAHTOA, or anything that you use to understand the definitions of trigonometry. trigonometric ratios. So we're basically going to use Pythagoras theorem as well as the definitions of trigonometric ratios to solve this. So in this one, you are asked to determine the length of AC, the sizes of angle A2 and angle B, the length of AD, the length of DB, as well as the length of AB in this triangle. So basically, that's what we're going to be doing. But I prefer that we do both these examples, example 1 and example 2, writing down. So now I want you to take down this diagram specifically, and then we are going to quickly solve these two problems, example 1 and example 2, and I prefer that we do them practically. So in other words, I explain as I write down. So I hope you have copied the diagram down, then we are going to solve. Right, like the first example, I've decided to just copy it down. There it is, example 1, determine the following. Remember, the triangle is given. There is the triangle PQR, right? So the first question was saying determine the magnitude of angle Q as well as angle R. And the second question said determine the length of PQ. Now, what we are going to do is we are going to determine first the magnitude of the two angles, angle Q and angle R. So we are solving now 1, right? So in 1.1, we are going to say what is it that we know and what is it that we are calculating, right? We are finding angle Q, this angle. We are to calculate that angle. Now we need to check what is it that is given, right? So when we look at it, we'll see that we are given that side, which is the side which is opposite, as well as this side, and this side is the one opposite to 90 degrees, which means it is the hypotenuse. So which trig function are we going to use therefore? Remember, we can use SOHCAHTOA. So we can see we have O and H. So we have O and H, which means we are going to use sine there. So which means sine of angle Q will be equal to opposite to angle Q. Opposite to angle Q is 24 over hypotenuse is 25. And then ours now is just to press the calculator and get the answer. Remember, to get angle Q, you must press shift sign of what was on the right hand side. So we are going to press shift sign of 24 divided by 25. Shift or second function, sine of 24 divided by 25, right? Shift sign of 24 divided by 25. Then we press is equal to, and then the answer that we get there is 73.73. We get the answer 73.73. If we are asked to round to one decimal digit, so it's going to be 73.7. So the answer is 73.7 degrees, right? Then the second question is find the angle of R. Now, we now know that this angle is 73.7 degrees. So there are two ways that I'm thinking of immediately in finding angle R. The first one is to use what we have just used here. So angle R, in other words, we can still find angle R by saying angle R, what is it that is given? We are given 24 as the side as well as 25. If we want to stick to what was given originally, which is what we always encourage, that use what was given in originally, that is the originally given information is very important. So which means we will say we want to calculate angle R, and then when we look at it, we will see that we are having 24 and 25. So 24 to angle R is adjacent and 25 is hypotenuse. So in other words, we now have the adjacent and the hypotenuse. Then we go to our SOHCAHTOA and check which trig function are we going to use, and we will see that it is this one. So we use now cos of angle R will be equal to what? It will be equal to adjacent, which is 24 divided by 25. So once again, we use our calculator and angle R. To find angle R, so we are going to use our calculator. We are going to press shift cos this time of 24 24 divided by 25 divided by 25 is equal to, and our calculator is going to give us 16.26, which is 16.3 if we correct to one decimal digit. Now remember that this now is 16.3 degrees. Another way of doing this would be to use Euclidean geometry, especially when you know this one. Once you know this one, and remember you also know that angle, so you would just say angle R, that would be your R would be equal to 180 degrees minus the two given angles, that is 90 degrees and minus 73.7 degrees. 180 degrees minus 90 degrees minus 73.7 degrees. So you would still use a calculator and say 180 degrees minus 90 degrees minus 73.7 degrees. You would still get your answer as 16.3. 16.3. That would be still your angle 16.3 using now Euclidean geometry. So which means you can incorporate Euclidean geometry here. You can still use it, especially if you know two angles of a triangle, right? Then 1.2, the length of PQ. The length of PQ now, that length, the length of PQ, that length, the length of PQ. Now there again I see many ways of doing that, but if you want to use the originally given information, you can still use the main theorem of Pythagoras. That is theorem of Pythagoras, which you can use there. But if you want to use trigonometry, as our topic is on trigonometry, you that you have calculated now this angle as 73.7, and then you want this side. Now this side is adjacent to 73.7. So it means you want to calculate adjacent side. Then you can use any of the two given sides. You can either use this one, which is O. You can use that one. You can use that one, which is O, or you can use this one, which is hypotenuse. So you can either use AO or AH. So you will decide. So when you go there, if you look at AO, you will see that that is going to be tan. If you look at AH, that is going to be cos still of that angle. So I will just prefer to use tan for this one, but remember you can use cos as well. So I will just use tan. So tan of 73.7 degrees now will be equal to adjacent. Remember will be equal to opposite. Remember tan is opposite over adjacent. Tan is opposite over adjacent. So which means tan of 73.7 will be opposite, which is going to be 24 divided by adjacent, opposite over adjacent, 24 divided by PQ. And then now you know how to maneuver. Now in mathematics, you take this PQ, remember this thing is over 1, you can take this PQ there and that tan 73 there. So it will be PQ is equal to 24 divided by tan 73.7 degrees, and the correct answer will be equal to, and then you just press your calculator. Before you just press your calculator, and it's going to be 24 divided by tan 73.7, which is going to give you an answer which is going to be 7. So it's approximately equal to 7. It's approximately equal to 7, right? But you could have used Pythagoras theorem as well. Remember, you could have used Pythagoras theorem as well by saying PQ squared plus P squared. So PQ squared plus PR squared, which is 24 squared, will be equal to 25 squared. And now that will be Pythagoras theorem. Pythagoras theorem as a reason. Now you would have to put a reason, just like you would have to put a reason there when you are using what you call Euclidean geometry to find the third angle and say sum of angles of a triangle. Sum of angles of a triangle. Here you just mentioned Pythagoras theorem, and then yours is just to say now PQ squared or PQ. Let's say PQ squared will be equal to 25 squared. Then that 24 squared goes, it becomes negative 24 squared, and therefore your PQ will be equal to square root of that answer. So which means your PQ will be square root of will be the square root of 25 minus 24. 25 squared minus 24 squared. So your PQ will be equal to square root of 25 squared minus 24 squared. That will be your answer there. And then your answer will obviously be equal to 7. So your answer for PQ will be equal to 7, right? So there are many ways of solving one problem in mathematics, and you must realize that, okay? So that is basically the first example that we had to talk about. So I want you to look at it briefly before we can pass on and do example number 2. Right, let's now go to example number 2. Example number 2, I hope you copied down the diagram. I also decided to copy down the questions so that we can do what we see here. We can do what we see, or we can talk about what we see. Right, so once again, you've got that triangle, main triangle ABC, and remember at angle A, that is angle BC, there is 90 degrees, as well as angle D somewhere, that is angle ADB or angle AC. Each of those, in fact, is 90 degrees. Then you are to calculate now the length of AC. That's the first question, the length of AC. Now you look at it again and see, okay, length of AC. Look at it and say, okay, I've got AC. What is AC? Which angle am I given? I am given 60 degrees, right? So AC is opposite that angle, which is also 90 degrees. So which means it is the hypotenuse, right? It is the hypotenuse. And remember, we're still going to be using SOHCAHTOA mainly. SOHCAHTOA, or that just the definitions of trigonometric ratios. And then we'll see that you are having hypotenuse that you are calculating, and you've got angle 60. And what is it that is given? Also, it is adjacent. So it means you are given adjacent side, you are calculating hypotenuse. So it means you are given adjacent side, you are calculating hypotenuse. So which trig function are you going to use? Cos, right? So in 2.1, we're going to use cos. So we're going to say cos 60 degrees is equal to adjacent, which is square root of 6, divided by hypotenuse, which is AC, what we are looking for. Then remember that this is divided by 1, so we can simply cross multiply or make AC the subject. Therefore, AC will be square root of 6 divided by cos 60 degrees. And then we simply press the calculator there. Square root of 6 divided by square root of 6 divided by cos of 60 degrees. Cos of 60 degrees, right? Cos of 60 degrees. Answer will be 2 square root 6. 2 square root 6. That is basically how you do your 2.1. Then now know that this is 2 square root of 6. And then you continue and answer 2.2 now. The size of angle A2 and angle B. Angle A2 and angle B. Angle A2 and angle B. The simplest way is you use Euclidean geometry here, because you know that this is 60 degrees, that is 90 degrees, and therefore that will be 30 degrees, because you just take your calculator and say my angle A2 is equal to 180 degrees minus 90 degrees minus 60 degrees, because I know that this is 90 and that is 60, and then you get the answer as 30 degrees. Reason will be sum of angles of triangle. Angles of triangle. Angles of a triangle. The alternative way of using now trigonometry will obviously be to try and use what was given initially. And you want to find this angle, which you're going to say, you're going to refer it as angle A2, right? So now that you know that this is 260, it's easy, because you will just say this angle, I'm having this angle and I want to calculate the hypotenuse. I know the hypotenuse as well as the side which is opposite A2, which is square root of 6. So it means I know the opposite, I know the hypotenuse. So which means I can simply use my sine. So which means you can say sine of angle A2 will be equal to opposite, right? Square root of 6 divided by hypotenuse, which is 2 square root of 6, 2 square root of 6, and the answer will just be, if we simplify that one, 2 or 0,5. Therefore, angle A2 will be equal to, you take your calculator, you press shift sign of, what is it, 1 divided by 2 or 0,5. 1 divided by 2 or 0,5 is equal to, and then the answer that you'll get will be 30 degrees. So you can still use trigonometry to get that 30 degrees, right? To get that 30 degrees. 2.3, right? 2.3. 2.3, you are asked to calculate, oh sorry, angle B as well. Angle B, you are also asked to find that angle. Angle B, that angle B. You are not done yet. You are also asked to calculate angle B. You can use the same approach that you used to find angle A2 by using Euclidean geometry, and say if this angle is 60 degrees and that one is 90 degrees and that one. So in that big triangle, that is the main triangle, in that main triangle, I know that this is 90 and that is 60. So what is that one? And therefore angle B will simply be equal to 30 degrees. Will simply be equal to 30 degrees. And then 2.3, angle B will be equal to 30 degrees. Angle B will be equal to 30 degrees, right? 2.3, you are now asked to find the length of AD, which is this one. The length of AD, which is this length, the side which is inside that particular triangle, angle AD. So it's easy here. You were given that this is square root of 6. You were given 60 degrees. Now we are looking for the side opposite to 60 degrees. Opposite to 60 degrees, and you know the side which is adjacent to 60 degrees. So you are having O and A, so which means that you can use, you are going to use tan is opposite over adjacent, so which means it will be tan of 60 degrees is equal to, opposite is what you are looking for, which is AD, over adjacent, which is going to be square root of 6, and then this is over 1. Remember to cross multiply, so AD is sine 60 divided, sine 60 is equal to AD over square root of 6. Therefore AD will be equal to square root 6 times tan 60 degrees. And then you can simply press your calculator there. You can simply press your calculator and say square root of 6 multiplied by tan 60 degrees, 60 degrees. And then the answer will be 3 square root 2. 3 square root of 2. That will be the answer for that. So basically, it's just the matter of using this software very well. So if you look at 2.4 now, the length of DB, you now know that this side is 3 square root 2. So you'll be focusing on this triangle. So you now know that is 30 degrees and this is 3 square root 2. So it's very simple. Again, you are looking for DB. So what is DB to 30 degrees? DB to 30 degrees is adjacent, and what is AD is opposite. So which means you're still going to use tan. So tan 30 degrees will be equal to opposite, which is 3 square root 2 over adjacent, which is DB. And therefore, your DB will be as this is over 1, so DB will go there and tan 30 will go there. It will be 3 square root 2 divided by tan 30 degrees, and then you simply press the calculator there. Then you simply press the calculator. 3 square root 2 divide by tan 30. Divide by tan 30. So the answer, what will be the answer? The answer will be 3 square root 6. The answer will be 3 square root 6. 3 square root 6. Right? Then the last one, which is 2.5. 2.5, you have to calculate the length of AB now. The length of AB, once again, AB is just the hypotenuse of that triangle. It's just the hypotenuse of that triangle. So you can still use opposite as well as hypotenuse. So you can still use opposite as well as hypotenuse. So which means that will be sine. So sine 30 degrees will be opposite, which is 3 square root 2 over hypotenuse, which is what you are looking for, and what you are looking for is obviously AB. And then this is over 1, so you can do mathematics calculations or manipulations. AB will be 3 square root 2 divided by sine 30 degrees. And once more, you can still use a calculator. 3 square root 2 divided by sine 30, divided by sine 30, divided by sine 30, then you will get the answer as 6 square root 2. So the answer for AB, will be 6 square root 2. That will be the answer. So basically, that's how you use your right-angled triangles to solve problems, or use your trigonometry to solve triangles that are right-angled triangles. So in our next lesson, we are going to be looking at triangles which are non-right-angled triangles. For now, just take your textbook, take your question paper, and even question papers from previous grades, grade 10 and grade 11, and look for right-angled triangles and try and solve right-angled triangles. Our next lesson will now be on non-right-angled triangles, and we shall be focusing on sine rule first, then the following lesson cosine rule, the following lesson area rule, and the last lesson will just be looking at three-dimensional figures, on how to use trigonometry to solve three-dimensional figures. I hope you understood today's concepts that we're trying to unpack to you, and do as many examples as you can. Remember, practice makes perfect, so you must practice, practice, and practice. Thank you very much.